Welcome back to Vijay Academy. In this video, I'll be explaining question number 30 from the sample paper. So the question is, prove that a parallelogram circumscribing a circle is a rhombus. So we are supposed to prove that a parallelogram is a rhombus. So here it's given that parallelogram circumscribing a circle. Let us understand this first. So a parallelogram circumscribing a circle means a parallelogram should be drawn around a circle in such a way that the sides of a parallelogram should touch the circle. So you can see in the figure, so the sides AB, BC, CD and DA of a parallelogram ABCD touches the circle at 4 points. So these points, the points of contacts are named as P, Q, R and S. So we are supposed to prove that this parallelogram is a rhombus. So now first let us name this. First let us write the given. So it's given that ABCD is a parallelogram. ABCD is a parallelogram circumscribing a circle. Parallelogram circumscribing a circle. And we are supposed to prove that ABCD is a rhombus. So to prove a parallelogram as a rhombus, we have to prove a pair of adjacent sides of a parallelogram are equal. A pair of adjacent sides of a parallelogram are equal, then all sides will become equal. So we can say that it is a rhombus. So now we are supposed to prove that ABCD is a rhombus. So to prove ABCD is a rhombus, first let us apply the theorem which is the tangents drawn from an external point to a circle are equal. So in this figure, the points A, B, C and D are the external points to the circle. So the tangents drawn from these points are equal. So let us write the proof. So the first one, let me write AP equals to AS. So these are the tangents drawn from external points to a circle. They are equal. So AP equals to AS. So let me take this as equation 1. And second, let me write BP equals to BQ. They are the tangents drawn from external point B. And next, let me write CR equals to DR. Tangents drawn from, sorry, not DR, which is CR. CR equals to CQ. CR equals to CQ, which are drawn from the external point C. So take this as equation 3. And then last one, dr equals to ds. Take this as equation 4. For all these 4 equations, the only one reason, that is, we can write one reason, that is the tangents drawn from an external point are equal. Tangents drawn from an external point are equal. Now make sure that you write AP and BP, CR and DR in the LHS. Because when we add these 4 equations, let us put this AP and BP together and make it as AP and BP together as AB. Similarly, CR and DR together, let us write it as CD. So that is the reason. So write the segments of AB and CD in the LHS and the segments of other 2 sides in the RHS. Now by adding these 4 equations, we get that on adding 1, 2, 3 and 4, we get AP equals to, AP plus BP plus CR plus DR equals to AS plus BQ plus CQ plus DS. So now in the place of AP plus BQ, in the place of AP plus BQ together is AB. Similarly, in the place of CR plus DR, we can write it as CD, and then AS and DS together we can write it as AD. Then BQ and CQ together we can write it as BC. So let us write that in the next step. So here we can write in the LHS AB plus CD equals to AD plus BC. So now we got that the sum of opposite sides of a parallelogram are equal. So that is AB plus CD equals to AD plus BC. Now we know that in parallelogram opposite sides are equal. So now we can replace CD by AB. Here we can replace CD by AB. In the LHS we get AB plus AB, and also replace BC by AD. The reason is CD equals to AB and BC equals to AD. Opposite sides of a parallelogram are equal. Now we can write this as 2 times AB equals to 2 times AD, and 2 gets cancelled, and therefore we can write AB equals to AD. Now we came to know that the adjacent sides are equal. A pair of adjacent sides are equal. We already know that in a parallelogram opposite sides are equal. So from these two we can write that all the 4 sides are equal. AB equals to BC equals to CD equals to DA. Therefore we can write that ABCD is a rhombus. ABCD is a rhombus. Now there is one more question in this, which is in the figure XY and X dash Y dash are 2 parallel tangents to a circle with center O, and another tangent AB with point of contact C intersecting XY at A and X dash Y dash at B. So what is the measure of angle AOB? So the figure is given in the question itself. So the diagram is given like this. Now we need to prove that, means we need to find the angle AOB, the measure of the angle AOB. So to find the measure of the angle AOB, let us do some construction. So you are supposed to write the given and to find. So given is XY is parallel to. So in the given we are supposed to write that XY is parallel to X dash Y dash, and also we have to write that a tangent AB is drawn at point of contact C intersecting XY at A, intersecting XY at A, and X dash Y dash at B. Now to find, we have to find that angle AOB. So we have to find the angle AOB. Now for this, to find the angle AOB, let us draw OC, means let us join OC. So that comes under construction. So extra construction must be written under construction. So join OC. So when you join OC, we get more triangles. And now let us apply the congruency of triangles. So in the proof, means in the answer, so first let us take the triangle APO and the triangle ACO. So in triangle APO and triangle ACO, from these two triangles we know that AP and AC are equal. They are the tangents drawn from an external point to a circle. So AP equals to AC. The reason tangents drawn from external point, are equal. Now what are the other measurements equal from these two triangles? The measurements angle P and angle C are 90 degree each. angle P and angle C are 90 degree each because the radius is perpendicular to tangent. Radius is perpendicular to tangent is the reason. And then we know that AO equals to AO, which is a common side. AO equals to AO, common side. Now from this information, from these three measurements, equality of these three measurements, we can write that triangle APO is congruent to triangle ACO. Here we are using RHS congruence rule because we have taken one right angle and hypotenuse OA is an hypotenuse, and then AP and AC are the sides, one side of a triangle. So we proved that APO is congruent to triangle ACO. From this, after proving these two triangles are congruent, then we can write that angle AOP and angle AOC are equal from CPCT. So now I can write that angle AOP equals to angle AOC. So I can write angle AOP equals to angle AOC, and let me mark this as X and X. Equal angles as X and X. The reason is CPCT. Now similarly you can prove the other two triangles which are BOQ and the triangle BOC. So we can prove these two triangles also similar in the same manner. So I can directly write that similarly triangle BOC is congruent to triangle BOQ by RHS congruence rule, and therefore I can write that angle BOC equals to angle BOQ, both are equals to Y. So let us take this as Y. So which is CPCT. Corresponding parts of congruent triangles are congruent. Now let me apply the straight angle property on the line POQ. On the line POQ, the sum of the angles at O. So the sum of the angles at O is 180 degree. So let me write that angle AOP plus angle AOC plus angle COB plus angle BOQ equals to 180 degree. The reason is straight angle. The sum of the angles formed at a point on a straight line is 180 degree. Now AOP and AOC, they are equal, so let us replace them by X and X. And COB and BOQ are equal, so let us replace them by Y and Y. So which is equals to 180 degree. Now adding this, we get 2x plus 2y equals to 180 degree. And now dividing the equation by 2, since all the terms of this equation consist 2 as a common factor, so we can divide the whole equation by 2, and now we get x plus y equals to 90 degree. Now look at the angle AOB. So angle AOB equals to x plus y. So x plus y together is angle AOB in the figure. So now I can replace x plus y by angle AOB. Now we got to know that angle AOB equals to 90 degree. So children, I will be sharing more videos and more sample papers explanation. So please subscribe to my channel and click on the bell icon to receive the notifications. Thank you, children.